The other thing you have to remember is the difference between the pre-ganglionic and the post-ganglionic with myelination and the Ramey. We'll revisit that. So, revisit looking at the parasympathetic. What's going on? Cranial nerve 3. Now, when you learn the cranial nerves, you'll learn that some of them, these 4, have parasympathetic fibers. Some have sensory fibers, some have motor fibers, some have both or all 3. But the point is, these have parasympathetic fibers. Cranial nerve 3, synapses at the ciliary ganglion. So this is the presynaptic axon. Here's the synapse. This is the postsynaptic axon. And it interacts with the eye. So mostly what we're talking about here is the iris, the ciliary muscle, etc. Okay? This ganglion is just behind the eye. So it's very close to the eye. So we're okay with cranial nerve 3. All right. Now, number 7 here. Comes on out, bifurcates. So the axon bifurcates. That's not unusual, by the way. One branch synapses at the pterygopalatine ganglion. This then has a postsynaptic or a postganglionic axon that bifurcates, synapsing in the nasal mucosa. Nasal mucosa is a special type of tissue. It's the mucosal layer is the surface. There's a little bit of smooth muscle under it, and the synapse is occurring there. That's why you, with a parasympathetic response, can have a runny nose. Okay? And the other branch synapses with the lacrimal gland. Oh, glandular tissue once again. So when you have this parasympathetic input, cranial nerve 7 to the to the pterygopalatine ganglion here, that's going to affect your nasal mucosa and your lacrimal gland. So you're crying. How many times do you notice that you're crying and you really have to blow your nose? It's like, I can't breathe. Well, some of that is due to lacrimal secretions entering your nasal cavity, but some of it is due to the actual increase of secretion within the nasal mucosa. So are we okay there? All right. The other branch, so we go to the pterygopalatine up here, and then we branch down to the submandibular ganglion, going to various glands in the mouth. The submandibular, which is down below the mandible, and the sublingual, which is at the base of your tongue. This is going to contribute to the production of digestive enzymes. Oh, well now that makes sense. Parasympathetic, rest and digest. If you're going to digest food, that process starts in your mouth. So this should be pretty straightforward. Finally, number 9 comes out, synapses at the otic ganglion. Otic. Otic. You know what otic means? What is an otolaryngologist? What?
Ears.
Ears. Otic is ears. Otolaryngologist is an ear and throat guy. Yeah. So, okay. So this is close to your ear, the otic. And the parotid gland sits right back here. you're of a generation that my guess is none of you had the mumps. Anybody have the mumps? You had the mumps?
Yeah.
Okay, were you vaccinated?
I think so. I don't know. I'm not sure.
Mumps?
I had, yeah. I think it was one side.
One side, yeah, that's not unusual. But typically, the vaccination for mumps virus is so good that I rarely have a student anymore that had mumps. Once again, parotid gland is a digestive gland. So, okay? You should know these 4 ganglia. You should know, where does the preganglionic axon cell body come from? So, ciliary ganglion, it comes from cranial nerve 3. Pterygopalatin ganglion, it comes from cranial nerve 7. Submandibular comes from cranial nerve 7. Otic, cranial nerve 9. Okay? You should know the targets. Cool? Questions? All right. Now we come to the major driving force of the parasympathetic nervous system, parasympathetic division of the autonomic nervous system, which is cranial nerve 10, the vagus, comes on out. And one of the first major issues is the cardiopulmonary plexus. I will always refer to this as the cardiopulmonary plexus. The reality here is, where do I draw the line in here to separate out the pulmonary from the cardiac? I don't know. I can't do it. If I can't do it, I don't expect you to do it. So now, from here, we are going to innervate the heart and the lungs. Notice, both of these synapses take place within the target. And that's all they're showing you there. Okay? There are actually multiple synapses involved. Yeah?
Like overthinking this, does it innervate the lung or does it innervate the diaphragm?
This does not innervate the diaphragm. This actually innervates lung tissue. It can also, there are innervation. What innervates the diaphragm? The phrenic nerve. So there's a whole bunch of breathing mechanisms within the lung as well. These all involve the bronchioles. Now you remember this is all smooth muscle now. They have to be able to dilate and constrict. So, yeah. What does this lead to? Bronchodilation or bronchoconstriction?
Constriction.
Constriction. Why? How do you know that?
You don't
You don't need
need as much oxygen in there.
to move as much air. Okay? And I'm not knocking your concept of need oxygen, but needing oxygen also means you need to offload CO2. So it changes the movement of the air with both oxygen and CO2. Cool. So as we continue in the abdominal cavity now, so up to that point we were in the thoracic cavity. We now have the celiac plexus. That's what this is. This whole thing. Okay? Don't try to dissect that into different pieces. Don't try to say the superior, the middle, the inferior. Don't. It's all the celiac plexus. You're going to synapse with the liver for releasing a wide variety of enzymes, enzymatic action. Remember, for digestion to occur, we need to release from the liver bile. Bile's made in the liver. It is stored in the gallbladder. So, rest and digest. The liver is making and releasing bile. The gallbladder is going to be squeezable. You're going to cause constriction of the gallbladder, which is going to squeeze out bile. Yeah?
What if you don't have a gallbladder?
If you don't have a gallbladder, that can't happen. However, so coming from the liver, we have in through here this common
It's a bile duct.
It's a common bile duct is what it is. So you are, let's say, one of those people that have gallstones.
I did.
You did.
I almost died from that.
Okay, and the reason you almost died from it was because when you start to fill the gallbladder up with stones, you start to leak digestive enzymes into you. And what do they do to you? They start to digest you, all right? Mostly what they start is breaking up fat. They start to destroy fats in you. Believe it or not, all cells are comprised of a lot of fat. The lipids are very important. They emulsify lipids, so they start emulsifying you. So what they did was they removed your gallbladder. Now, this is still patent. The difference is now, as you produce, you have a sphincter here, just before you dump into your intestine. This sphincter will actually close when you're not eating, okay? You haven't eaten a meal. And so the liver produces bile, and this fills up and it backs up into the gallbladder. All right. So the gallbladder fills up. We've taken that away. Now what this means is, this is going to be relaxed more, and you're going to continuously drip bile into your colon, into your small intestine. What that means is you might be a little more sensitive to a fatty meal. Okay, so if you were to eat a meal with a high fat content, under normal circumstances, the gallbladder would squeeze, push out more bile. And so you can't do that, obviously. But other than that, everything's fine, everything's cool. This does not impact a person's life expectancy. It only impacts how you digest fat during a fatty meal. What would happen before, I'm not saying it was with you, but typically with people with gallbladder disease, as you build up gallstones and you squeeze, what would happen is the gallstones would block the movement here.
That's why I almost,
Yeah.
yeah.
And nothing would be coming out, and you couldn't digest the fat at all. You couldn't emulsify it, not really digest it.
Yeah, I had a
So-
stone stuck in the duct.
Yep, it's not pretty. We think about stones, okay? My guess is when you think about stones, you think about things like this. However, bile is a complex of a bunch of different salts. And if you've ever seen how salts precipitate out, they're more like that. Okay, the bile duct is a very small duct, and as you build up stones in the duct and the gallbladder goes to contract, all of these spires are sticking into you. So it's pretty ugly. Yes. What else about that? I don't know.